Okay, so our learning goal today is I can solve equations in one variable, so it has all x's in it, or all a's, or all m's, or whatever the variable is. But this time there'll be variable terms on both sides of the equation. So how are we going to go about solving those kind? Okay, so that's our next type. And by the way, just a little note. This Thursday is your first kind of like big quiz. The one that is you have to have the mandatory 75% or higher on, or you do a retake on it. It's a mandatory retake. And so we have been through lessons 1 through 4, and now we're doing 5 today, and then that's what the quiz is over, is 1.1 through 1.5. So again, you need to study this lesson. We're just going to go right into solving some of these types of problems. We're actually doing from the bottom of page 40, we're doing the check it out problems that go with example 1. Make sure you study example 1, 2 on your own, okay? So we have 4b, that's not a 6, that's a b. 4b plus 2 equals 3b. And I say or because there's really a couple of different ways we can go about solving this. And chances are that's what's going to happen between you and maybe even the person sitting at your table. They're going to do it one way and you're going to attack it a different way. But the first thing we always need to look for when we're solving equations now, he said, is we have to check to see can they be simplified first. So what are our simplifying steps we're going to look for? How can an equation be simplified or renamed before we even start solving it? What kinds of things should we look for? This is just from last week, folks. Mara.
Like terms.
Like terms. Can we combine any like terms? Now, like terms meaning on one side of the equation or the other. In other words, you go by sides then when you're simplifying. Are there like terms on the same side that can be combined? Are there like terms on the same side that can be combined? Okay, what else? Distributive property. Is there any multiplication over parentheses, over addition or subtraction that you need to take care of? And again, that's on one side and or the other. Can you simplify by doing some distributive property? So tell me, in 4b plus 2 equals 3b, is there any simplifying to do? Any simplifying to make? Looks like we have some like terms, right? But are they on the same side? No. So this is one of those, we don't need to do any simplifying, and it's an equation where in reality we have variable terms on both sides, so how are we going to deal with those? Not to confuse the issue, but remember when we were solving equations that have more than one operation, I said undo what first? Addition and subtraction or multiplication and division? Addition and subtraction. I said usually that'll be a better route to take. Well now, when we have variable terms on both sides, I'm going to kind of like change that up. I'm going to say, you know what? Deal with the variable terms first. Just deal with those first, and then we'll go from there. So in this one, the first way we're going to solve it is this way. We're going to take away 4b, because that'll remove them from the left side. If we take it away on that side, we have to take it away on the right side also. Make sure your b's look like b's, not 6's. And then we're left with 2 on the left side. And what's 3b take away 4b? Negative 1b. So now what would we do? Is it ready to say done? Okay, what are we going to do then? B is being multiplied by negative 1, so we need to divide both sides by negative 1. 2 divided by negative 1, class, is negative 2. And over here we have b. Our solution is b is equal to negative 2. Well, what if somebody says, you know what, I solved it a different way, but I still got the same answer? You should be like, cool, because we should both get the same answer for the same equation. So what if instead your friend says, I took care of the b's on this side first. I wanted to get those moved, so I subtracted 3b from both sides. Is that legit? Sure. Okay, so now we would have 4b take away 3b. 1b. What's a 1b? Just a b, right? Let's just put b. What's over there? 0. We're going to put the word nothing? No, we're going to put 0. Is 0 a legitimate number? Absolutely, it lives on the number line. 0 is a legitimate number. We need to show, you know what? We have 0 over here now. And now we just need to subtract 2 from both sides. And we get b equals -2. 0 take away 2 is -2. Same solution. I'm not even going to circle it because I don't want us to think, you know what, there's 2 different solutions for this. We were just solving it, going about it a different way. Yes, Kurt?
How did we get the 0
On the right side? Because when you have 3 b's and you take away 3 b's, they're gone. There's not a constant to bring down these. Okay, any other questions? Again, where should our answer check out? In the original equation. If you wanted to make sure you had the right solution, you would check it out in the original equation. By the way, I'm not requiring you to do check problems today, but you're of course always welcome to do them even when you're not required. Okay? Anybody want to suggest what a good way to start this next one? Do we need to simplify first of all? Any simplifying need doing? Any like terms on the same side? Any distributive property to do? No. So then, now what? Okay, Tessa, what do you want to do?
Subtract 0.3 on both sides.
Subtract 0.3? Like that? Oh. Oh, but don't we need a y attached to that? Is that a big deal?
Yes.
Oh, sure is. Yeah, it is. Sorry. Have to make a big deal out of it. 0 and 5/10 is all that's left on the left side. How many y's do we have now? It's like taking 30 cents away from 70 cents. Come on, people. 40 cents. 0 and 4/10 y. What would be a good next move to make now? Carter?
Subtract 3.3 both sides.
Subtract, okay, because it's subtraction, undo subtraction.
Or add.
How about we add? Yeah. How about we add 3/10 to both sides? And now we have what over here? 50 cents plus 30 cents.
0.8.
0.8, 80 cents. Over on the other side, these guys are gone. We have our 4/10 y. What are we going to do now? Divide by what y is being multiplied by. So we're going to take each side and divide by the 0 and 4/10. And when I have decimals, I always think of money. I got 80 cents and it's being divided by 40 cents. Or in other words, how many times can you take 40 cents out of 80 cents? Twice. 2 is our y value. Again, if it was the right solution, it should check in the original equation, not after you got it, like a little bit shorter, so you're like, this looks like a lot easier to check from this point. Because you might have made a mistake along the way. Well, you know how I talked about renaming equations when they had fractions in them? How about when they have decimals in them? Anybody kind of hate decimals too? You're like, I don't even like to work with decimals. Oh, not very many of you, huh? Well, couldn't we rename this equation by multiplying each piece by 10? Would that eliminate the decimals? So in other words, let's just write down that equation again. 0 and 5/10 y, or no, there's no y behind that 5/10, sorry. Plus 0 and 3/10 y equals 0 and 7/10 y minus 0 and 3/10. Multiplying by 10, remember when you multiply or divide, you have to do it to every single piece of the equation. I don't care how many pieces there are. So we have to do it to the 0 and 5/10, we have to do it to the 0 and 3/10 y, 0 and 7/10 y, 0 and 3/10. Multiplying by 10, what shortcut is there for that? The decimal, right? How many places? One place, so we just go like this. Ta-da, ta-da, ta-da. What if all of them were decimals? Would we still have to move the decimal the same amount in all of them? Yes, we would. So now we have 5 plus 3 3y equals 7y minus 3. Maybe you like the equation better like that. So you can always rename an equation if you would prefer. We should still get the same solution. Go ahead, solve that quick. See if you do. See if you get y equals 2. There. Well, did you solve it necessarily the same exact way I did? Bet not. I bet a lot of you subtracted 3y from both sides first, didn't you? So it doesn't matter. You're better off still get the same solution. It's just I did it so that I could show you that this is my main concern right here. When we have 7y take away 7y, oftentimes students forget that that 3 is not a positive 3, it is a negative 3. It has to come down as a negative 3, okay? Questions? Okay, let's go back to the back side then and see what we got back there. Okay, now we're doing checkout problems that go with example 2. So, what's the first thing we're going to look for? Like terms, simplifying steps, right? Okay, looks like, but remember when we actually wrote these down, we said let's look for distributive property first and then like terms. So, do we have any distributive property to do? Yes. So we would do this distributive property, and we would have a half of a b plus a half of a 6. What's half of 6? 3. And is there any distributive property to do on the other side? Any combining like terms to do on the other side? No? Now this would be a good spot. Maybe you want to rename your equation, or maybe you just want to work with it like it is because you're like, oh, you know what? They're both halves, so maybe it won't be so bad after all. So there are no like terms here, no like terms on the other side, so we're ready to start solving this, right? What do you want to do? Subtract a half of b, okay? After we subtract that half of b from this side, we have a positive 3 left. 3 halves of a b and a half of a b, and taking the half of b away, what do we have? We have a 1b. 1 and a half, isn't 3 halves 1 and a half? So we have 1 and a half, take away a half. Wouldn't that be 1?
Yes.
So it'd be a 1b. Well, that means we could just write b, couldn't we? Yeah. Or you can write, 2 halves b to start with, because that's really what it is. 3 halves b minus 1 half b is 2 halves b, and 2 halves is 1, and 1 is I don't really need it. And now we do what to both sides? Add 1, don't we? B equals 4. Without showing our work, let's do a quick check problem. 4 goes in for B. 4 plus 6 is? 10. Half of 10 is? 5. Keep that thought. That's the left side. Okay? 3 halves of B. Well, B is 4. So 1 and a half times 4. 1 times 4 is? And another half of 4 is 2. So altogether we get 6. Oh, and 6 take away 1 is? And 6 take away 1 is, oh, look at that, it checks. Okay. Now, I want to show you something because I know I'm going to have some brave souls in here who are going to be like, I want to rename that equation right away from the beginning. I am going to get rid of fractions in the very beginning because I don't really want to deal with them. So I want to show you that you can, but I want to make sure you're hearing me on this. We said if you're going to multiply or divide, you have to do it to what? every piece, every term of the equation. So this right here, that's a whole term right there. 1/2 times b plus 6, that's all stuck together. That is one piece right there. So when we multiply, we're going to multiply by the reciprocal of 1/2, which is 2, and that'll get rid of that 1/2 for us. And we do not have to worry about this b plus 6 because this whole thing is one whole term. So we can just go like this. And then we would have to take the other side, both pieces, that's now 2 pieces. We would have to take both of those times 2 over 1. So now we would have b plus 6 equals, oh well, these guys will cancel out. I got a 3b minus 2. Look at there. Friendlier, right? But be careful. You have to know how to rename properly. You have to be able to understand when you multiply or divide, what you do to each piece, what are pieces then, what are terms then. Questions at all? Okay, I want you to get the next one ready to solve. That's all I want you to do. I can already see it needs some simplifying. You get the next one ready to solve. Okay, what is the simplified name for this equation? In other words, its new name before we start solving it. What you got, Joe?
3x plus 6 equals 2x plus 4.
Do you agree with that?
Yes.
Yes. Okay. So we have some like terms on the left side that can be combined. The constants of positive 15, take away 9, positive 6. We have some distributive property to do on the right side. Are we ready to solve? Absolutely. Go ahead, solve it. You decide how you're going to solve it, and we'll see what you all get. Check me out, see if I'm right. You did not have to solve it the same exact step order steps as I did, but we should all end up showing work and getting the same answer. Do we agree? Anybody? Good. Questions? There's a whole lot of stuff going on now. We have some simplifying to do. We have more than one operation happening in these. We have variable terms on both sides. You know, there's a slew of stuff to keep straight. What do I do, when and why, and you know, don't just be like, oh, I don't know, eventually I'll get an answer. Just throw something down. Okay, now is when we're going to our chapter 1 pretest, number 12. We're going to turn to it because that's where you're going to find the problem. I did not write it down here. If I remember, out of all of my Algebra 1 students, you know, out of about 60 students, I feel like I had a handful of people who had this problem. Hi. Yeah. So, can we get it right now? Yes, we can, because now we're going to find how, what we could have done, what kind of an equation we could have set up to help us problem solve this. So this is, would you read through and tell me what x is going to represent? Because that's how we always start. Number of hours. Okay, so we're looking for the number of hours. Okay, so number of hours. Let's write that down. X is the number of hours. So in the end, our final answer should be hours, right? Well, I believe in this question, the question was after how many hours would the cost be the same no matter which landscaping company you went with? Am I right? Is that what this problem is about? Well, cost is the same. What does that sound like to you? What mathematical symbol does that sound like? Equals. We need to know when one company's cost is equal to the other one's cost. So it'd be good to know what the cost, how we could represent the cost for each of them, right? So how could we represent the cost, the total cost, based on the number of hours X for the first landscaping company? What, Connor?
100 plus 15x.
So looking at this is what I'm gonna say I believe is going on. There's a $100 one-time fee, plus you pay $15 for every hour. Correct? Is that what it is? This is a good algebraic expression to represent the cost for the first landscaping company. Okay? How about the second landscaping company then? Write an algebraic expression for their cost. Okay, who's got it for me? Say it. 75 plus 17x. Okay? So that represents how much the total cost would be for the second landscaping company. What are we going to do for an equation now then? Connor?
100 plus 15x equals 75 plus 17x.
Set them equal to each other. And so, do we have any simplifying to do first? No, they'd be busy. So. All done, Austin? Austin. Keep doing it all year long. Person, all done? Okay, would you bring your paper up here and with your magic finger, will you show us what you did? What can everybody keep looking? You don't need paper, okay, I'm doing it. I think I'm gonna change the color to blue. Okay. What is that, 12 and what? A half? Okay. Is there a label for that? Okay, according to Person, the answer to this is, thank you very much. According to Person, the answer to this is 12 and a half hours. Do we agree?
Yes.
Yes? So what's true of 12 and a half hours? That's the same, doesn't matter which landscaping company you choose. What's going to happen at 13 hours or more? One of them is going to be more expensive than the other, right? And what's going to happen at 12 hours or less? The other is going to be more expensive than the other. So one of them's at one time when they do more than 12 and a half hours or less than 12 and a half hours, that's when their costs are going to differ. But at 12 and a half, if you know that the job's going to take 12 and a half hours, it doesn't matter which company you go with. If you know it's going to take, they bid it, they say it's going to take us 12 and a half hours to do this. Does it matter which company you go with? No, the cost is the same. Did you have to find that cost, or did you just have to find the number of hours? Number of hours. Oh, okay. So now you know how to do that problem, right? Okay. Questions? Okay, homework time.